We're in the solar system simulation today, and we're going to look at the motion of Earth and Mars. So here, for example, we'll start up time. We can see them moving in their orbits. We'll speed up time a little bit to make it a little bit easier to see. Okay, so it looks like Earth is catching up with Mars. They're both traveling in the same direction. Earth looks like it's going a little bit faster. Now let's get a different perspective. So for example, if we zoom down, whoa, what's going on there? We're on the surface of Mars, looking out towards the sun, watching Mars's moons go by and the Earth go by. So think about it one more time. On Mars, looking towards the sun, and there was the Earth going by as we watched it. So look at that again. I'll slow down time. So there are the moons traveling by really quickly, and there's the Earth traveling in its orbit. What happens if we zoom back out to here and then zoom down to the surface of Earth? Now if we're on the surface of Earth looking towards the sun, we can't see Mars. So we would have to rotate around. Oh, there's Mars. Okay, so now if we start up time, the moon travels around us really fast. And there, it looks like Mars is traveling the opposite direction as the moon is. Why? Why is it traveling that direction? So think about where we are in the orbit again. We're looking at the moon and Mars. Zoom back down. Looks like Mars is getting closer to the sun. Why would it look like that if you're on Earth looking towards the sun? Is Mars going to go in front of the sun or behind the sun? What's happening here? Are we going to have an eclipse? No, it travels behind, right? Because here we are looking at the sun. Mars is exactly on the other side of its orbit. So now if we zoom back down, we'll rotate around to make you be able to see that a little easier. So there, Mars goes on the other side of its orbit. So we find that the simulation really helps people to visualize the different relative positions of the planets.